So quiz tomorrow, 10 questions on 5.1 and 5.2. It says quiz number 1 review, but it's actually our second quiz. No, just 10 questions total. So number 1 says find the indicated real nth root of A. So the n is our index. So here we're looking for the 4th root of 16. So let's break it down. What are factors of 16? 4 and 4 and 2 factors of 4. How many of a kind are we circling here? 4 of a kind. So we'd circle our 4 of a kind. So what comes to the outside? 2. Now if it's an even index, we have to put the plus or minus. So it'd be plus or minus 2. Yes, even index needs a plus or minus. And let's also do C. So we have the 5th root of negative 32. What are 2 factors of 32? 4 and 8. What else? 2 and 2. 2 factors of 8. 2 and 4 and 2 factors of 4. 2 and 2. We're circling how many of a kind here? 5. So I have 5 2's. So what would our answer be here? Just negative 2. Because when it's an odd index, you don't put the plus or minus, but because it's negative on the inside, our answer has to be negative.
So if it was even, then you need the plus or minus.
If it was even, then you'd put the plus or minus. So the 5th root of negative 32 we said was negative 2, but if we had the 5th root of just 32, that would be just 2. Any questions there? Let's do number 2. We want to find the real solutions of the equations. So we are solving for x. We need to get the x all by itself. So how can I move the 1/3 to the other side? Awesome. Multiply both sides times 3. So 3 times 1/3 would cancel. So we have x to the 4th power is equal to, what's 27 times 3? 81. Awesome. If you're not sure, write it out. Do 27 times 3. 3 times 7 is 21. 3 times 2 is 6 plus 2, 81. All right, now how do we get rid of the 4th power? The square root, but what's our index going to be? 4. And remember, when we take an even index, what do we need in our answer? Plus or minus. Now let's simplify the 4th root of 81. What are 2 factors of 81? 9 and 9. 2 factors of 9? 3 and 3, 3, 3. We're circling how many of a kind? Do we have 4 of a kind? So what would our answer be? Plus or minus 3. So anytime you take an even index, so an even square root, needs a plus or minus. All right, let's do B also. What should we do first to solve for B? Subtract 10. So x cubed is equal to negative 8. Then what would we do? We take the cubed root of both sides, so it cancels out. So x is equal to, let's find the cubed root of negative 8. What are 2 factors of 8? 2 and 4, and 2 factors of 4. So we circle our group of 3 because our index is 3. So what would our answer be here? Negative 2. Perfect, because it was a negative 8 on the inside. Since it's an odd index, it keeps the same sign as the inside. 3 says evaluate without a calculator. So you will not have a calculator for tomorrow. So when we evaluate, remember our index is the denominator. So the number on the bottom goes out front. So we have the 6th root of 64. What are 2 factors of 64? 8 and 8, and 2 factors of 8, 2 and 4, and then 4 breaks down into 2 and 2. We're circling how many of a kind here? 6 of a kind. Do we have 6 of a kind? Yes. So what would our answer here be? Plus or minus 2. All right, let's do B also. Actually, let's do C. C is a good one because it's got a negative. So a couple different things that we could do first. What would you recommend that we do first? Awesome. We can get rid of the negative by putting it over 1. So we have 1 over 16 to the power of 3 over 4. Let's change it into a radical so we could simplify. What would our index out front of the radical be? 4. Remember, the index is the denominator. So we have the 4th root of 16 cubed. What are 2 factors of 16? 8 and 2 and 2 factors of 8. 4 and 2 and 2 factors of 4. 2 and 2. We're circling how many of a kind here? 4 of a kind. So a 2 comes out. So we have 1 over 2, but we still have that exponent of 3. So 2 to the 3rd power. So don't forget, if you have an exponent, it just stays up top. What is 2 to the 3rd power? Awesome, 8. Remember, it's like saying 2 times 2 times 2. So 1 over 8. You don't need it here when you're evaluating. So same thing for the other one. The only questions that you really need the plus or minus for when you put the radical there. So something like the first ones require the plus or minus, and definitely when solving. So I think that the first ones only require the plus or minus to kind of prepare you for the solving. But when you're just evaluating, you don't need the plus or minus. It's just going to be whatever sign it ends up with. So like for A in number 3, you don't really need the plus or minus. I won't take off points if you put it. So it's not, I mean, it's good practice to remember if you're taking the even index. But if you don't put it for questions like these where you're evaluating, it's fine. Yeah. All right, let's look at 4. So we're using properties of exponents to simplify. So in A, when we're dividing, how could we combine these together?
You have to change the exponent on top.
The exponent on top would be 1. Now how can we combine? When we're dividing, what would we do? Subtract. We subtract the exponent. So our base stays the same. We do 1 minus 1/4. Make sure you know how to add and subtract fractions for the quiz tomorrow. 1 we can change to be 1 over 1. We need a common denominator, so we change it to 4 over 4. So 4 minus 1 would be 3 over 4. Let's look at B. So inside we have the same base, so we can combine them together. When we're multiplying, how would we combine them? Add. So we have 4 to the power of negative 2 over 3 plus 1 over 3 to the power of negative 1. So let's add our exponents together first, then we'll worry about the negative 1. Inside, we already have a common denominator, so we can just add the numerators together. Negative 2 plus 1 would be negative 1, so 4 to the power of negative 1 over 3 times negative 1, or to the power of negative 1. What do we do when we have a power raised to a power? Multiply. So this turns into 4 to the power of 1/3, positive 1/3. All right, for C. What should we do first for C? Distribute. We want to distribute the exponent to both things inside. We can't combine the numbers together inside because they don't have the same base. So we want to distribute the exponent. So this would be 9 to the power of 3 to the power of negative 1/3 and 5 to the power of negative 1/3. Well, what do we do when we have a power raised to a power? multiply. So this turns into 9 to the power of, what is 3 times 1? Negative 1/3. Negative 1. And then on the bottom, it would just be 5 to the power of negative 1/3. Now we don't like negative exponents, so what do we need to do to make them positive? You move them to make it positive. So move it to the bottom. So moving the whole number that has the negative exponent changes the sign. So it would become 9 to the power of positive 1, but do we need the 1 as our exponent? No. And then 5 to the power of 1/3 would be on top. So 5 to the power of 1/3 over 9. All right, let's do E. What should we do for E? So if they all have the same index, we can combine them all together under the same index. So we have 6 times 72 over 2. Now 6 times 72 would be 6 times 7 is 42, plus 1 would be 43. So 432 over 2. And then we could divide it by 2. So 2 goes into 4 twice, 2 goes into 3 one time with 1 left over, and 2 goes into 12, 6. So we have the cubed root of 216. 216 looks a little bit familiar, but if you aren't sure what the cubed root of 216 is, let's break it down. What are 2 factors of 216? It's even, so what's going to go into it? 2 and 108. Just divide it by 2 to find out what the other number is. But any even number, you know that 2 is going to go into it. What's a factor of 108? 2 and 54. And 2 factors of 54. 2 and 27. Or you could say 9 and 6. That would work too. So 2, 2, 2. 2 factors of 27. 9 and 3. And 2 factors of 9. 3 and 3. How many of a kind are we circling? 3 of a kind. So we've got 3 2s and 3 3s. So what's going to come to the outside? 2 times 3, which would be 6. All right, let's do number 5. So we have to write the expression in simplest form. So when we have a square root on the bottom, and especially when we have 2 terms, we have to rationalize but multiply by the conjugate. What's the conjugate of 3 plus square root 2? 3 minus square root 2. So we have to multiply that on the top and the bottom. 3 minus square root 2. On top, we just distribute the 6, so that would be 18 minus 6 square root 2. And then on the bottom, you can either FOIL or use your conjugate shortcut. Our conjugate shortcut is a squared minus b squared. What's our a? 3. So this would be 3 squared minus, what's our b? Square root 2 squared. What's 3 squared? 9. And square root 2 squared would be 2, because the square root and the squared cancel. And 9 minus 2? 7. So 7 would be in our denominator. This would be our answer. So for number 6, let's do B. So we can't have a fraction in a square root. We also can't have a square root in the denominator of a fraction. So that means that we have to rationalize. So we need to make sure that our denominator is a whole number. So I'm going to split these up just so we can deal with the top and the bottom separate. So the cubed root of 7 over the cubed root of 4. So let's see what we need to multiply to our denominator to make it a whole number. Because our goal is to make the denominator a whole number. Whatever we multiply to the denominator, we also have to multiply to the top too. So what are 2 factors of 4? 2 and 2. How many do I need to make a perfect whole number? 3 of them. So how many am I missing? Just 1. So I'm going to multiply it by the cubed root of 2. Whatever your index is going to stay the same when you multiply. So the cubed root of 2 to the top and the bottom. Now on the bottom, we have a perfect set of 3. So what's our denominator going to be? 2. Thank you. And then on the top, what is the cubed root of 7 times the cubed root of 2? The cubed root of 14. Perfect. And you can't divide 2 into the 14. You cannot divide a whole number into the radical. Only if they have the same radical you can divide them. Let's do C. So C, if we combine them together, we can't simplify 3 and over 8. So let's break it down. What are 2 factors of 8? 4 and 2. And 2 factors of 4? 2 and 2. How many of a kind do I need to make a perfect whole number? 2. So I've got 2 of a kind, but then I have an odd 2 out. So how many 2's am I missing to make it a perfect whole number? Just 1, because that 1, 2 needs its pair. So I'm going to multiply by the square root of 2 to the top and the bottom. So now, what's going to come out on the denominator? 2 times 2, which would be 4, because we had 2 circles of 2, so 2 2's come out. And then what would our numerator be? Square root 6, perfect, because we can multiply the 2 numbers together. The only case you might see where the index is different would be if like the bases were the same. So if you had something like the 4th root of x over like the cubed root of x. Because if the bases are the same and you're dividing, you can combine them together by subtracting. So you could change the exponents to be x to the power of 1 over 4 and x to the power of 1 over 3. And then you would subtract them together, so x to the power of 1 over 4 minus 1 over 3. So something like that where the bases are the same. But if it had numbers and they were different, like b and c, the exponents need to be the same in order to rationalize. All right, let's take a look at 8. Can I add these together? Yes, because the variable part is exactly the same. So I just add the coefficients. This would be 16x to the 3/2 power. What if I had something like 2x to the 3/4 power minus 6 times the 4th root of x cubed?
Yes.
Can we combine them together? Are the variable parts the same? Yeah, they are, because the index here would be 4, so our denominator would change to 4. So this would be minus 6x to the 3/4 power, which they would be the same. So we just combine the coefficients. So what would we get here? Negative 4x to the 3/4 power. And you could leave it if you wanted to change this one to be the 4th root of x cubed, and you could have negative 4 times the 4th root of x cubed. These are the same. Both of these would be correct. But just know that sometimes it may not look exactly the same. You may have to change it if it's in radical form to exponent form in order to combine them. All right, we'll do 9, both of them, A and B. So for A, we have the cubed root of 64 times r to the 4th power times s to the 8th power. So let's break each one down separate. What are 2 factors of 64? 8 and 8, and 2 factors of 8? 4 and 2, and 2 factors of 4 would be 2 and 2. I'm circling how many of a kind here? 3 of a kind. So I've got 3 2's and 3 2's. So what's going to come to the outside? Perfect. 2 2's. So 2 times 2 would be 4. So let's do the same thing with the r's. How many r's do I have inside? 4, because it's r to the 4th power. How many am I circling? 3 of a kind. So 3 r's get circled. So how many come to the outside? Just 1, because I only have 1 circle. How many stay on the inside? 1. So I keep the cubed root, because whatever the index is in the question, it has to stay the same in our answer, and just 1 r stays on the inside. Now let's do the same thing with the s's. How many s's do I have inside? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many of a kind am I circling? 3. So how many come to the outside? 2 of them. S squared comes out. How many stay on the inside? 2. So S squared stays on the inside because 2 did not get circled. And that would be our answer. All right, for B, we have the 5th root of k to the 5th power divided by n to the 7th power. So we can't have a fraction inside our radical, so let's break it apart. We have the 5th root of k to the 5th power over the 5th root of n to the 7th power. Can we simplify the top? What would it simplify to? Just k, perfect. Sometimes, some people may think the 5th root and the 5th power cancel, just like how our square root and squared cancel. But if you need to write it out, write it out. We have k times k times k times k times k. We circle our group of 5, so k comes out. We can do the same thing on the bottom. We have 7 ends. 1, 2, 3, 4, 5, 6, 7. How many of a kind are we circling? So circle 5 of them. How many come to the outside? 1, because we have 1 circle. Then the 5th root, how many stay on the inside? 2. Can I leave a radical in my denominator? No. Can't have a radical in your denominator. So that means that we have to rationalize. So I have 2 ends inside the radical. How many do I need to make a perfect set? 5. So how many more do I need? 3 more. So I'm going to multiply it by the 5th root of n to the 3rd power. And whatever I multiply to the bottom, I also have to multiply to the top, the 5th root of n to the 3rd power. So now we have 5 n's. So that means another n is going to come out. So if I already had an n on the bottom, and I took another n out, how many n's do I have on the bottom now? N squared, perfect. Because 1 n was already outside, this was my other n. So we would change that to be n squared on the bottom. Now on the top, can I combine k and the 5th root of n to the 3rd power? Nope, so we would just leave it as k times the 5th root of n to the 3rd power. And that would be our answer. Yeah, 7, since they're the same variable part, you would just subtract. So 3 minus 14 would be negative 11 times the cubed root of xy. What if they were different? What if I had the 3xy plus 3 times the square root of xy? Could I add these together? No. So this would be as simplified as it can go. So you can only combine them when they are the same variable part.